Here it is a fifth day, Prof.R.Surendran from Government College of Technology. So in Government College of Technology, we are organizing GATE classes for different students in different Government College of Engineering in Tamil Nadu, and as well as for our mentee institution, NIT Arunachal Pradesh and Government Engineering College Jagadalpur. So this is the fifth day. The subject is metal cutting and machining operations. We are covering one by one all the topics. So we are going to refresh all the theoretical concept in this classes. So what is the difference between the structured learning and unstructured learning? In structured learning, each subject is covered step by step. When you follow the schedule, it will be easy for your preparation of the exam. When you are not in unstructured learning, when you follow the unstructured learning, the process of preparation get delayed. So students, whenever for a particular week a separate subject is allotted, you have to cover step by step procedure, and it will be useful for your preparation. So you can, for this is second subject, already engineering mechanics has been covered. Now we are moving to the metal cutting and machining operations. So in metal cutting and machining operation, all the concepts are discussed. So practice the question step by step, and practice makes you confidence. You can easily deal with the exams, and you can achieve the topmost rank in the exam, and you can achieve the success in your life. Thank you. So now we are going to discuss about the jigs and fixture. Here first of all we should know what do you mean by jig. Jig is used to hold the workpiece. So hold the workpiece and guide the tool. So for both the purpose holding and guiding, this jig is used. For fixture, the fixture is the only holding device. So we have to classify the difference between the jigs and fixture. So hold and guide means jigs, only guiding means fixture. So we are having the principle of location. In the principle of location, the workpiece is located by 6 pins. So we are having 6 pins. With the help of 6 pins, the workpiece is located, which restrict the 9 degrees of freedom. So which restrict the 9 degrees of freedom. So in the principle of location, 6 pins, 9, it restricts the 9 degrees of freedom. Next we are going to discuss about the principle of the least point. It is in this technique only minimum locating point should be used to secure location of the workpiece. So what we are doing, we are going to secure the location of the workpiece with the minimum locating point. So next we are going to discuss is principle of extreme position. Locating point should be taken away from the another as possible as any one workpiece surface. So it is far away, it is taken far away. So that is the principle of extreme position. Next, principle of mutually perpendicular plane. Here locating points are in such a way that positions are mutually perpendicular planes. So here we have known the difference between jigs and fixture, and the principle of location, and the principle of least point, principle of extreme position, and principle of mutually perpendicular planes. So we are having, we can put it in the crisp way. 3-to-1 principle, 6 pins are used, restrict degree of freedom 6. Principle of least point, concentrate on the only one plane, and the principle of extreme position should be taken far as possible. Principle of mutually perpendicular, it should be perpendicular to each other. Next, we are using the G codes and M codes in the CNC system. Any one of the G codes is repeatedly asked in the exam, so we should know by one. G00 represent the rapid transverse, and the G01 represent the linear interpolation. It is used for linear interpolation, and G02 it is for circular interpolation. But in clockwise, and the G03 should be for circular interpolation counterclockwise, and G04 the code is used for dwell, and G10 is used for input cutter of set data, and G17 selection of XY plane in the milling operations. So G21 in millimeter, G28 return to the reference point, and G32 it is used in thread cutting in turning, G40 is used for cancel offset compensation. G41 used for cutter offset compensation left of the part surface. So similarly for cutter offset compensation right of the part surface we are using G42, and G50 is used for specifying the location of the coordinate system. Similarly G92 used in milling and drilling operation. G94 feet per minute in the milling and drilling. So here we are having some other codes. G98 is used for feet in minute in tanning, and G90 it is for program in absolute coordinates. We are having two types of coordinates, absolute coordinates and incremental coordinates. For absolute coordinates it is G90, for incremental coordinates it is G91. So and M codes are the accessory codes. So MG00 is for program stop, and M01 is optional program stop, and M02 is for machine stop. M03 is used to start the spindle in clockwise direction. So M04 is used for start the spindle in counterclockwise direction. So counterclockwise direction it is 4, clockwise it is 3. So M05 is used for spindle stop, M06 is for tool change, M07 is turn the cutting fluid on, M08 in mist, turn cutting fluid off is M09, automatic clamping we are using M10, automatic unclamping we are using M11. So to start the spindle clockwise and the cutting fluid on we have to use M13. Similarly M14 for counterclockwise, and the spindle and the cutting fluid off M17, turn spindle off at the oriented position we are using M19, end of the program M30. Now we are going to discuss about the fundamentals of the machinings. So we are going to discuss one by one: lathe, drilling machine, milling machine, grinding machine, gear manufacturing machine. All the machines are basic details are discussed here. So you have to keen on watching these things. So first of all we are going to discuss the lathe bed. Lathe bed is made up of closed grain structure cast iron. The cutting operation cannot be performed in lathe is square hole cannot be made in the lathe. The size of the lathe is specified by the height of the centers, length between the centers, swing diameter over bed, swing diameter over carriage. These are the things we are going to describe the lathe specification. So here swing diameter over bed is compared to the swing diameter over carriage, this one is greater. So swing diameter over bed is more compared to that of carriage. So important lathe spindle, we are having lathe spindle are made having the external screw thread, and you can remember it have the internal taper. Lathe spindle having the internal taper and external screw threads. So the operation which can be performed in the lathe are knurling. Knurling is the operation of embossing diamond shaped pattern on the surface. So eccentric turning where that the center of the workpiece is deviated. And we are having the device edge strock. In the edge strock we are having the center of the spindle placed in the edge strock. The center of the spindle is termed as live center. Because it is able to rotate, it is called as live center. In tail strock the spindle center is called as dead center because it is not able to rotate. Dead means not able to rotate, live means able to rotate. And the carriage, in carriage what are the components, what are the important thing in carriage means we are having cross slide, tool post, apron and compound rest. Cross slide, tool post, apron and compound rest are the important thing in the. So next we should know the function of the each and everything. Cross slide is used to move radially, so it can be used to move radially. And compound rest, this compound rest is for swivel for tool positioning and adjustment, and power feed not available, it can be used. Apron is a mechanism is used for manual or mechanical movement of carriage. And off nut, what do you mean by off nut? Off nut is a nut which has to engage with the lead screw. The lathe carriage, it lock the lathe carriage to the connect the LL. Off nut can be also called as split nut. It connect the lathe carriage to the top lead screw. Lathe carriage to the top lead screw. So power is transmitted by lead screw to the carriage. And we should know about the lead screw. Lead screw has the left hand thread. Lead screw has the left hand thread. Here we can provide the backlash eliminator. Tumbler gear. We know the tumbler gear. Tumbler gear gives the desired movement for the desired direction of the movement in the carriage. The carriage move to what direction, it has to be decided by the tumbler gear. And mandrel is used to holding the reamer. Already previous drilled hole can be held by with the help of mandrel. Chasing dial. This chasing dial is a special attachment used for the thread cutting operations. So for thread cutting, we are using chasing dial. And the step cone pulley. The step cone pulley in the lathe is used to change the spindle speed. It has to change the spindle speed. And we are having steady rest. Steady rest is used to hold the heavy and long workpiece. When the workpiece is long or heavy, it can be held by steady rest. And face plate. Face plate is nothing but it is a plate. It is a plate having different size hole. So hole size may be varied. So it has a variety of holes. So for holding the irregular shaped workpiece, we are using face plate. So next we are having pipe center. What is that pipe center? It is used to hold the hollow jobs. So when the job itself hollow, we have to use hold the hollow job by with the help of pipe center. Next we are having the different operation. What do you mean by facing? Facing is the operation to produce a flat surface or reducing the length. The operation in which length is reduced is termed as facing. And relief tanning. Relief tanning is the process of removing material. Removing the material. Next is relief tanning. Relief tanning is the process of removing material from the previously tanned hole. We are having previously tanned hole, so we are making along the same axis within the limits of tanned area. So that operation is called as relief tanning. Next, champering. Champering is a removing of the sharp edge. Removing of the sharp edge. So it can be, the sharp edge can be removed. The sharp edge can be removed. So this is the chamfered portion. Okay. It facilitates the entry of the mating parts. So for whenever there is a mating part, the entry can be facilitated by the operation called champering. Okay. So it purpose is avoid sharp edge. So sharp edge, when we handle the workpiece with sharp edge, what happen? Our hand, it can cause a injury. So next, knurling. Knurling is a embossing. It is a embossing of the diamond shaped pattern on the surface. So for example, we are having the workpiece. So up to this region, we are embossing the diamond shaped pattern. For the gripping purpose, when we hold the workpiece, for the gripping purpose, the knurling can be provided. Spot facing, achieving smoothing and squaring. Yes, spot facing means smoothing and squaring the surface. Smoothing, squaring the surface is called as spot facing. Next is counter boring. Counter boring is enlarging the hole cylindrically up to certain extent. So we are having the hole. It has to be enlarged up to certain length. It has to be enlarged up to certain length. So it is counter boring. Next is counter sinking, means we are conically enlarged up to certain length. So spot facing means smoothing and squaring. This is spot facing. Smoothing and squaring at the end of the hole, it is a spot facing. So this one is a spot facing, and this one is a counter boring, and this one is a counter sinking. So we can remember all these operations easily. Next we are having chuck, 4-jaw chuck. 4-jaw chuck is used for heavy speed shaft. It can be used for heavy speed shaft, and this 4-jaw chuck can be centering can be done accurately. In 4-jaw chuck, centering can be done accurately. 4-jaw chuck for machining brass casting. So for casting the product coming from the casting easily held by the 4-jaw chuck. And the combination chuck. Combination chuck is for quick setting and accurate centering. Quick setting, accurate centering, combination chuck can be used. Collet chuck is used for small size cylindrical job, and large number of components can be produced. Small size cylindrical job can be held by the collet chuck. Magnetic chuck, mass production. Magnetic chuck, mass production, large number of components. 4-jaw self-centering chuck is used for setting up heavy and irregular workpiece. 3-jaw chuck, in the 3-jaw chuck we can incorporate the scroll plate. This 3-jaw chuck is the self-centered. What it means self-centered? All the 3 jaws are moved simultaneously. Next, we should know about the taper turning operation. Taper turning operation can be achieved by the following these things. It can be by broad nose tool. It can be used for turn short length. Broad nose tool is used for short length, and the setting over tailstock method is used. It is called as offset method. So here live center and dead center are not equally stressed, so it can be held by the live center and dead center. Both the live center and dead center are not equally stressed in this operation. So taper for the entire length of job is found out by that formula d minus d by 2. Taper for the part length, d minus d by 2 into capital L by small l. Well, capital L is the full length, small l is the part length. Next we are going to discuss about the swiveling over the compound rest method. Here short but steep taper can be produced. Tool is feed at an angle. Swiveling over the compound rest, tool is feed at an angle, low production capacity. This is for low production capacity. Then next we are going to discuss about the taper attachment method. The taper attachment method is used for steeper taper on long pieces. Accurate taper can be produced, and the most important, internal taper. The internal taper can be produced by the taper attachment method. And we are having combining feed method. Here longitudinal feed and cross feed are combined together simultaneously to produce the taper turning. So we are having 5 methods. The first method is broad nose tool. The second method is tailstock set over method. The third method is swiveling the compound rest. The fourth method is taper attachment method. The next one is combining feed method. With all these methods, the taper can be produced in the cylindrical job. Next, what do you mean by drilling? Drilling is a hole making operation. What is the principle behind that the drilling? What is the combined action of shear and extrusion take place? The cutting action always done by the tangential force. So we know that cutting power equal to tangential power force into cutting velocity. So tangential force is the important thing. It is maximum. Radial force is greater means radial force is irrelevant force. If it is greater means so surface finish is poor. Surface finish is poor. So drilling is an example of oblique cutting because 2 cutting edge come into the action. So multiple cutting edge come into the action. It is a oblique cutting. Drill spindle is made by Morse taper or reed taper. Similarly, lathe spindle also is made up of provided with Morse taper. This Morse taper is provided in lathe spindle. Similarly, in drill bit also the Morse taper. So it is in the ratio of 1:2. Horizontal into east vertical ratio is 1:20. So or some book it is 24 also it may be provided. So 1:20 or 24. So it is a horizontal vertical ratio of the Morse taper. Next, we are going to see about the types of drill. We are having several types of drill. First of all, we are going to discuss the flat drill. Flat drill means it is not suitable for drilling deep hole, is obsolete in modern drilling practice. So flat drill nowadays, modern drilling practice, it cannot be used. Next is straight fluted drill. The straight fluted drill is used for drilling. The straight fluted drill is used for drilling brass. And we have parallel shank drill. Parallel shank drill is used for drill. It is a drill with a zero rake. And a twist drill. It is the most commonly used drill is twist drill. Twist drill is made up of high speed steel. It is always twist drill is made up of high speed steel, and it is specified by the diameter of the drill bit and the material of the drill bit and shank. So diameter of the drill bit is the most relevant. Taper shank. So we are having two types of drill bit. One is parallel shank and another is taper shank. Most commonly used are taper shank. It is general. Straight shank drill are used only for small hole diameter, and extra length drill are used for extreme depth. High helix drill, when we drill as a helix angle more than usually 30 degrees is famous for helix angle. So high helix drill, it can be, so high helix drill, so we can go for deep hole drilling. Low helix drill, the helix angle is lesser, it can be used for thin sheet. And the core drill is used for enlarging the holes which are already made in casting. So casting holes enlarged by core drill. Core drill consists of 3 to 4 flutes. That is important. It is core drill also called as multi-flute drill. What we can call multi-flute drill. Okay. Next we are going to step drill. Step drill is 2 or more diameter along its length. So at a time 2 or more diameter can be produced. It can be possible by only step drill. So it need resharpening. So what is a step drill? We have to take care. It need resharpening. Next is subland drill. Subland drill is also called as dual cut drill. Subland drill also called as dual cut drill. It has the 2 distinct land, no need of resharpening. So subland drill, no need of resharpening. Step drill, need resharpening. Now we are going to discuss about the tungsten carbide tipped drill bit. It is used for drilling brittle material. So for example, glass is a brittle material, slate, ceramics. For drilling brittle material, so we can have the tungsten carbide tipped drill bit. And a single flute drill always used for soft material. Single flute drill always used for soft material. So next we are going to discuss about some of the features of the drills. Drills are made up of high speed steel, and the twist drill is belongs to the end cutting tool. Twist drill is belong to the end cutting tool. And here we are having some terminology. What do you mean by lips? Lips are cutting edge of the twist drill. Okay, lips are the cutting edge of the twist drill. And the drift is the tool to withdraw the drill from the sleeve. Flute are the helical groove. So we are having the drill bit is here and helical groove. This helical groove is the flute. Tang is at the end of the drill bit we are having tang prevent the drill slipping. So it is prevent the drill slip. So this flute can be used to form the cutting edge and chip to escape, cutting fluid supply and curl the chip. So it has the 4 function. The flute has 4 function. It forms the cutting edge where chips can be produced. It is a passage to chip to escape, and it curl the chip, and it is used to cutting fluid supply. Rack and pinion. Rack and pinion is used for up and down motion. With the help of when we rotate the hand wheel, it will move up, and when we rotate in another direction, it will move down. So for that, rack and pinion are used. Quill is used to produce the keyway. Next we are having the cutting material and different speed. For copper it is lesser. You can observe the different material: copper, mild steel, aluminum. For aluminum it is greater, 60 to 90, and copper it is lesser. Okay, it is a inference, that's all. So 18 to 30 minutes for copper, 18 to 30 meter per minute copper, 24 to 45 for mild steel, and 60 to 90 meter per minute for aluminum. So next thing we are going to discuss is types of drilling machine. This types of drilling machine: deep hole drilling machine is used to produce a rifle, crankshaft and long shaft. For all these things, this deep hole drilling is used. And a portable drilling machine can be specified by the maximum diameter it can hold. Okay, next is sensitive drilling machine. Sensitive drilling machine is used for only small hole and high speed. And upright drilling machine is used for medium size workpiece. Radial drilling machine is used for large and heavy workpiece. And gang drilling machine is used for workpiece requires several operation. When the workpiece requires several operation, the gang drilling machine is used. It consists of 4 to 6 spindle. You can easily remember 4 and 6 are the famous number in cricket. So for gang drilling machine we can use 4 to 6 spindle. And the multi-spindle drilling machine, all the drill are make the hole simultaneously. For engine housing, those holes can be produced by multi-spindle drilling machine. Okay, ultrasonic drilling machine is used for only brittle material. So you can see here it is a glass sheet, that too 1 mm dia can be produced by ultrasonic drilling. Next, drill bit, core drill. Core drill, it is used to already have the hole in the casting. In the casting product having the hole where that core drill is used to enlarge the hole. Reamer, what do you mean? What is the function of reamer? It is for smooth surface finish and accuracy, dimensional accuracy. And next is counterbore drill. Counterbore drill is used to enlarge the hole to a certain depth. And tab drill, it is for making threads. Now we are going to discuss about the important feature of the drill. Whenever there is a tool, it has some specific feature. So here we can observe helix angle. Helix angle is the angle between the leading edge of the land and the plane having the axis of drill. So helix angle is the angle between the leading edge of the land and the plane having the axis of drill. For example, so it is the plane having the so it is the leading edge. So that angle is the helix angle, leading edge and axis of the drill. Chisel edge angle is usually this helix angle is the equivalent to that of rake angle in single point cutting tool, and 30 degree normal value is 30 degree. And the chisel edge angle is the angle between the chisel edge and lip viewed from the end of the drill. We have to view from the end of the drill, and the chisel edge, the angle between chisel edge and lip viewed from the end of the edge, it is 120 degree to 135 degree. And the lip clearance angle, it is angle between flank and the plane right angle to the axis. Plane right angle to the axis means, so this is the plane right angle to the axis. So that is the lip clearance angle. And lip angle is the 60 to 80 degree. It is the cutting edge of the standard twist drill to the top edge found by the intersection of the flank. Point angle, two lips projected upon the parallel to the drill axis. Two lips are projected upon the parallel to the drill axis. It can be called as point angle. Point angle is usually 118 degree. So when lip angle is 0, what happens? The drill will not cut. So we are having comparison here. So marble, it is 80-degree point angle. Marble 80-degree point angle. Bakelite 90-degree, and stainless steel and odd nickel alloy 135. Soft material more than 118. Okay. And the fast helix drill 35-degree. Ferrous material 30-degree. Order material 10 to 13. And we can easily remember, for brass, bronze, bakelite, helix angle should be low. And aluminum and deep hole drilling and ductile material, it will be high. So I always A for A high and B low. For A high, B low. A for aluminum and B for brass, bronze, bakelite. Okay, so in that way you can easily remember, for A it is high and B it is low. Next, we are going to discuss about the process. So drilling is a hole making process. So boring is a hole enlarging process. Reaming is a hole finishing process. Trepanning is a making the larger hole without the drill bit. Counter boring, it is a enlarging the hole up to certain extent. Enlarging the hole cylindrically up to certain extent. Counter sinking, enlarging the hole conically up to certain extents. So that is the thing you should remember. Next, reaming. Next in our topic is reaming. Reaming is the hole finishing operation. So here the material is high speed steel, cast alloy and cemented carbide. It has low speed. Compared to drilling, it has low speed. But compared to drilling, it has high feed. Why? When we go with low feed, it will produce chatter, the vibration. So why it has go for low speed? It is efficient at the low speed. So for everything there may be reason behind that. So Reamer has low speed compared to drill bit because it is efficient at that cutting speed. And the feed is high because when we go for low feed, what happens? Chatter will be produced. And one more important point. The Reamer has more cutting edge compared to that of drill. It has more cutting edge. So next, we are going to discuss the types of Reamer. Types of Reamer are hand Reamer. Hand Reamer material to be removed is 0.01 mm. And right hand spiral Reamer is used for deep blind holes. Spiral fluted Reamer is used for making keyways. And shell Reamer, what we can call shell Reamer? A Reamer without shank is called a shell Reamer. Left hand spiral Reamer is used for soft material. Floating Reamer is used for correct the misalignment. Next, we are going to know about the Reamer holding tool. Reamer is held by mandrel. Now we are going to proceed with the milling operations. What do you mean by milling? Milling is a multi-point cutting tool. It can be used for flat, contoured and revolution surface. Flat, contoured, flat surface, contoured surface, revolution surface. Process of removing metal by feeding the work. Feeding the work against a rotating multi-point cutter. Here the cutter is rotating multi-point cutter. So we are having two types of milling, up milling and down milling. In up milling, we can have the cutter rotate in the opposite direction. In down milling, we are having the cutter rotate in the same direction of the tool feed direction. So in this way, we can classify the up milling and down milling. In up milling, you can have the cutter rotate in the opposite direction, and in down milling it is against the feed. So here cutting force 0 to max, that maximum to minimum. Here cutting force lift the tendency, it will throw the workpiece like that and it will hold the workpiece. Here tend to press, tend to lift. Okay, in up milling tend to lift, in down milling tend to press. And chip thickness is minimum at the beginning. Here chip thickness is minimum and maximum. Here this is the maximum and minimum. So surface finish is good here. You can see at the end minimum means surface finish is good. Tool life is longer, here more. And the simple fixture design. But all are advantage. Only one disadvantage in it necessitate backlash eliminator. So some error is there in down milling. So down milling or climb milling can be used for only new machine. It is used for new machine. The up milling can be used for new machine as well as old machine. So here in down milling, the chips can be disposed easily. The chip can be disposed easily, and the coolant can be poured directly. Specific power consumption is high. It can be used for thin sheet and high MRR and high efficiency. Milling cutter with high radial rake angle. So these are the specific features of the down milling. The chip can be disposed easily, and the coolant can be poured directly. In the specific power consumption is high. It can be used for thin sheet. It has high MRR and high efficiency. In milling cutter with high radial rake angle is used. Next, we are going to discuss the types of milling machine. In types of milling machine, we are having universal milling machine. Universal milling machine means it has 5. It can be rotated by, it can have the 5 different motion. An omniversal means 4. Omni means 4. Universal 5. Omniversal 4. Plane means 3. So what is that? Longitudinal, vertical and crosswise movement is here. Longitudinal, vertical, crosswise. Here instead of that, table can be tilted in the vertical plane, and here tilted vertical and horizontal. Horizontal plane and vertical plane. Here only vertical plane. Here longitudinal, moved crosswise and vertically. So 3 possible movement can be provided in plane milling machine. 4 possible motion can be provided in omniversal milling machine. 5 possible motion can be provided in universal milling machine. Next is planetary milling machine. In planetary milling machine, what happens? We are having internal and external threads of different pitch on the tapered surface. So next is saw milling. Saw milling is used to produce a narrow slot. Saw milling, narrow slot or grooves. Straddle milling. What do you mean by straddle milling? So we are having workpiece here. So it is the milling cutter can be holded by arbor. The milling cutter can be holded by arbor. So we are having 2 milling cutter holded by this is the arbor. This is the milling cutter holding tool. It is the arbor. So we are having 2 cutter, and the 2 cutter are, this is milling cutter 1 and milling cutter 2. This 2 cutter produce the surface like this. So it has produced a 2 vertical surface here. So that process is called as straddle milling. Straddle milling means 2 cutter. It can be easily remembered by 2D. In straddle, you can observe the D letter. It is 2. So D, 2 cutter. It can be used for making external bolt. So it can produce the external bolt. So 3, this one straddle, and again another direction, this surface can be produced, another direction, this can be produced. So external surface can be produced by the straddle milling. And the gang milling. Gang milling is operation of producing with 2 or more cutters simultaneously. It is the gang milling. So that is an important thing we should know. Now we are going to move about the shaper. Shaper is a machine which is used to produce a flat surface or a vertical inclined surface like that. So here the tool is reciprocates and work stationary. You can see the tool reciprocate, work stationary. So size of shaper specified by the length of the stroke or quick return ratio. The material is removed during the forward stroke. In the return stroke, it will come without removing the material. A shaper can cut grooves, keyways, slots. Large jobs on shaper are held by the clamps and bolts and squares. So why quick return mechanism are used in shaper? For decreasing the idle time. So return stroke, it is not cutting, so we are going to decrease idle time. So for that quick return mechanism is used. In quick return mechanism, the ram stroke length is proportional to the slotted arm length. So usually the usual quick return ratio is forward to return stroke is 3:2. In some cases it may be used 2:1 also. And ratchet and pawl mechanism, it is used for tool feed. Shaping is very slow, but it is used. But because of the short setup time and easy operation, cheap tooling. So surface cutting speed of the shaper is depends on the both work material and tool material. So next is planer. In planer, what happened? The work table in planer work reciprocate tool stationary. This is the planer. In planer work reciprocate tool stationary. So here the gooseneck tools are prepared on planers and slotters because digging in and scoring the work is minimum. Why gooseneck tools are prepared? Digging in and scoring is minimum. So clamping device on planer, puppet and toe dogs are used for holding thin piece, and V block is used for cylindrical work. For large size work we are using planar vise. Step block is for to hold the workpiece of different height. When we are having the workpiece of different height, it can be used by using the step block. Angle plate is the plate used for holding L-shaped workpiece. Planar jack is used for support the overhanging part. So these are the some of the planar work holding device, clamping device. So what is the difference between shaper and slotter? In shaper tool reciprocate, here also tool reciprocate, but in shaper tool reciprocate in horizontal axis, here vertical axis. So that is the main. Machine table has a linear movement. In slotter, machine table has linear as well as rotary movement. Next we are going to discuss about the broaching. The broaching is the operation, it is a reciprocating tool. It has a long tool which has reciprocate, it has the long tool, so it has a different teeth. So initially the teeth may be roughing teeth and finally it is a finishing teeth. So this is the roughing teeth and this is the finishing teeth. In between semi-finishing teeth or semi-roughing teeth. So roughing, semi-roughing and finishing. So in that way we can be obtained. So it may be called a semi-finishing teeth. Roughing teeth, semi-finishing teeth and finishing teeth. So it can pass, single pass, it produces the contour surface. So no feed separate motion is required. Here the successive number of successive teeth for increasing size is used. So made up of high speed steel, the important point is no feed is required in broaching. And the broach has roughing teeth and semi-finishing teeth and finishing teeth. So it has a small amount of finishing teeth as small amount of land. And roughing teeth is a rear teeth, it remove the maximum MRR. So what are surface? It can be produced by the broach. So we are having internal and external surface, circular and irregular surface, gear teeth and spline. So next we are going to discuss about the types of broach. Types of broach, push broach. Push broach is used for sizing and remove less metal. Okay, here less number of teeth. Push broach is used for sizing, it removes less metal because it has less number of teeth. Pull broach. Pull broach tool moves over the stationary work. Pull broach is similar to that of the action you are when you observe the action, what happens. So here tool moves and stationary work. Surface broach, entire work and tool over move each other. Entire work and tool move over each other. Continuous broach, work moves over the stationary tool. It is continuous broach, remember planer. Pull broach, remember shaper. Next we are moving to the grinding operation. Grinding operation is the surface finishing operation. The smooth surface finish can be obtained in the grinding. So it is machining, the basic purpose of grinding is machining odd materials, high quality surface with close tolerance and removal of excess material. So the odd material can be machined, high quality surface can be produced, and excess material such as burr we can be easily eliminated. So it is a grinding wheel. So in grinding wheel you can observe here these are the grains. So the grinding wheel, abrasive particles are bonding material. Abrasive particle are bonded together with the help of bonding material. And what is the projected? So it has the different features. So we are having structure. The different structure are used in the grinding wheel. Two types of structures are there. One is open structure, another one is closed structure. In open structure, space is more, closed structure, space is less. So open structure used for ductile material, closed structure is used for brittle material. The closed structure is used for brittle material, open structure is used for ductile material. So you can easily remember like this. Okay, you should form the mnemonic code. Okay, do BC like that. So ductile material, open structure, brittle material, closed structure, do BC. It is a code we have to remember for easy remembrance. So next we are going to discuss about the properties of abrasive grains. First of all, friability, ability to fracture of abrasive grain under pressure. So under pressure, ability to fracture of the grains is called as friability. Next is hardness. It is ability to scratch or penetrate the workpiece. So it has to penetrate the workpiece, then only the surface finish can be obtained. Size of the screen through which the grain will pass. Bond, it is a bond material used to hold the abrasive particle. When you stick the abrasive particle on surface, it has to be retained on the surface. For that, what is the thing we are using? We are using bond. Grade is the important thing which determines the hardness. So grade of the wheel is the ability to retain grit. Ability to retain grit is termed as grade. A softer material, odd grade, soft material, odd grade, and odd material, soft grade. So it is vice versa. And structure already we know that open structure, closed structure. So we are having do BC for structure. Ductile material, open structure, brittle material, closed structure. And the wheel specification can be shown below. So this is a wheel specification. You can see the 5-letter code. You can observe the 5-letter code here. It is very, very important for the mechanical engineer. Whenever you are going to purchase a grinding wheel, you have to mention this 5-letter code to purchase the grinding wheel. It has to specify it in some notation. So we should remember this is 5-letter code. So previous and at the front and rear, front and back, there is some manufacturer code. But we should remember the 5-letter. First number, last number are given to the manufacturer. So first, types of abrasive. So types of abrasive, we are having silicon carbide, for example, aluminum oxide, diamond. So CAD, you can easily remember CAD types of. So among these, any one of abrasive can be used. So it may be notated as C means carbide, A means aluminum oxide, C means carbide, and D means diamond. So grain size, for grain size it is 10 to 24 roughing. So less value rough, more value super finish, more value, less value is less, grain size value is less, it can be used for roughing operation. 10 to 24. 2 dozen, 10 to 24. Next is 30 to 60 medium, 70 to 180 finishing, 220 to 600 it is super finishing. And oddness are notated by the alphabet. You can up to H it is soft, up to H it is soft. After Q it is odd. So you should remember H, Q. So up to H soft, after Q odd. Okay, high quality. You should remember high quality. Before H soft, after Q odd. So in between these two it is medium. Structure. So 0 means dense, 16 means open. So in between we can vary 0 to 16. 16 means open, 16 means open, 0 means closed. So dense structure, open dense structure or closed structure. Okay. Type of bond. We are having different types of bond: vitrified bond, silicate bond, resinoid bond. So vitrified bond noted by the V. It can be glass material which produce the strong wheel. Mostly used bond is vitrified bond, and for silicate bond it is S, and resinoid bond it is the bakelite bond. Resinoid bond it is a bakelite bond, thermostatic material. So we are having some comparison here. The aluminum oxide is used for high tensile strength material. So you can see here high tensile strength material. Silicon carbide is used for low tensile strength material. Okay. So these are some of the example. And grain size. So soft material is used for ductile. So soft material, ductile material, coarse grain. So coarse grain size is used for ductile material. Fine grain size is used for brittle material or odd material. Okay, so for brittle material it is fine grain, ductile material it is a coarse grain. So these are the ductile material and brittle material we can use. Grade, high grade is used for soft material, soft grade is used for odd material. We already seen that. Structure, open structure and closed structure. Open structure 16, closed structure 0. We can easily remember 1 to 8, 9 to 15. So like that it can be varied. Bond, vitrified bond and manufacture number 93. So we should know about the different types of bond. We should know about the different types of bond. So resinoid bond is used for fine finishing, and vitrified bond commonly used. Silicate bond is for knife grinding, and shellac bond is used for tool grinding. Shellac bond is used for tool grinding for low heat generation. The odd material, wet condition is preferable. So soft material, dry condition is preferable. For soft material, dry condition is preferable. Odd material, wet condition is preferable. So what do you mean by grinding ratio? Volume of the metal removed from the workpiece to the top, volume of the metal removed from the grinding wheel. So this is the grinding ratio. When it is varies from 75 to 125, it is its usual value. For finished grinding it is 25 to 30. For finished grinding it is 25 to 30. GC means green grit silicon carbide. So when it is notated as GC, wherever you are observed the word GC in our grinding wheel specification, it is green grit silicon carbide. WA means white aluminum oxide. WA means white aluminum oxide. So what are the different parameters of the grinding wheel? We are having a grain depth of cut, peripheral speed, and the speed is limited by bond rigidity grinding operation. Okay, we are having limited speed. The speed has some restriction. So that restriction, why? Because of bond rigidity and grinding operations. Speed increases, the chip size will be reduced. When the speed increases at the constant, the chip size will be reduced. High speed, what happened to the high speed? It produced the crack. So crack is due to the heat generation. The grinding wheel has to be balanced frequently. Why? Because of the random wear. It is an important interview question. Why the grinding wheel has to be balanced frequently? Because of the individual random wear. So oddness, the oddness of the grinding wheel is represented by the alphabet. The oddness is represented by the alphabet. So it is a resistance exerted by the bond against the grinding stress. Okay. So it is amount and kind of bonding material is used. Hardness is determined by, it is a letter of alphabet, it is determined by the amount and kind of the bonding material used. Finish of the ground surface could be poor due to dulling. Dulling, when the abrasive grains are dull, so finishing cannot be obtained. Next, we are having the phenomena for the grinding wheel. So it is glazing and truing, dressing, loading. Loading is a clog. The particle get clogged in between the grains. So dressing is improving the cutting action, truing is restoring the cutting action, glazing is the wear of abrasive grains and the shiny appearance of the wheel. So because of the glazing, cutting capacity decreases. So this is the condition for the glazing, odd wheel. When we are having the odd wheel and high speed, glazing will be there. Next, we are having the types of grinding. Types of grinding: internal cylindrical grinding, external cylindrical grinding, surface grinding, face grinding, form grinding, flange grinding, snag grinding, transverse grinding. So internal cylindrical grinding means internal cylindrical holes can be made. External cylindrical grinding, tapered surface, straight or tapered surface can be produced. Surface grinding, flat surface in horizontal position, irregular curved, any surface can be concave, convex surface can be easily produced. Next, face grinding, flat surface in vertical position can be produced. And form grinding, to grind the shaft surface and inner hollow surface and splined shaft surface. For shaft surface, form grinding. Plunge grinding, the work rotate in the fixed position. The work rotate in the fixed position. Wheel feed to produce a cylinder equal to the shorter than the width of the wheel face. Okay. Plunge grinding, so there may be work rotate in the fixed position of the wheel, feeds to the produce a cylinder equal or shorter than the width of the wheel face by feeding the revolving wheel. So by feeding the revolving wheel. So this type of grinding is called as plunge grinding. So work rotate in the fixed position and the revolving wheel is feed into the work. Next is snag grinding. Snag grinding is to remove the considerable amount of metal. Here the accuracy is not the important phenomena. Accuracy of the trimming. So this is snag grinding is used for trimming. Next is transverse grinding. The work is reciprocate on the wheel feeds. The work is reciprocated on the wheeled feed. So that is a transverse grinding. Next, part of grinding. Part of grinding is the grinding in which peripheral speed is maximum. We are having two grinding, centered grinding and centerless grinding. In centered grinding, axisymmetric surface can be produced. In centerless grinding, we are having one grinding wheel and another regulating wheel. So in between the workpiece is grinded. So this is grinding wheel and regulating wheel. This is workpiece. So here regulating wheel slitted at the 0 to 8 degree. No feed is required. No feed is required. No separate, and it is used for mass production. Mass production. So these are the features of the centerless grinding. And universal grinding machine, in that headstock can be swiveled with respect to the table travel. In universal grinding machine, headstock can be swiveled with respect to the table travel. So these are the features of the centerless grinding. We are having actual feed equal to PDN sin alpha. So next, the workpiece center will be the above the line joining. So you can see the, so workpiece center. So this is center of the regulating wheel and workpiece center here. So it will be above the line joining. The regulating wheel is inclined to 0 to 8 degree. Wear and tear of the machine is less. So you can see in central grinding, wear is less, tear is less. It is suitable for long job, and no work holding device is required. So no work holding device in centralist grinding, because it has to be supported in between the regulating wheel and grinding wheel. And we are having cylindrical grinding. We are having three types of cylindrical grinding. This is cylindrical grinding. So through feed grinding, in feed grinding, end feed grinding. Through feed grinding is for long slender shaft, in feed grinding is for solder and formed surface, end feed grinding is for taper surface. So these are the three types of cylindrical grinding: through feed grinding, in feed grinding, end feed grinding. These three grindings are for different specific purpose: long slender shaft, through feed grinding; shoulders and formed surface, in feed grinding; taper, end feed grinding. Next is surface finishing operation. We are going to see in surface finishing operation lapping. In surface finishing operation we are having lapping. Lapping where loose dust type abrasive are used. Awning, it is correct the ovality of the hole. And super finishing where surface is produced. And buffing can be done by with the help of cotton fabric dipped in the grinding particles. Cotton fabric dipped in the grinding particle solutions, and it taken on and the operation can be fulfilled. And burnishing, we are removing the burrs. So these are the surface finishing operations. These are surface finishing operations. Here in lapping, producing geometrical true surface and sizing. In awning, correct waviness of the axis, correct the internal round holes can be produced. In super finishing, high quality surface finish. Okay, so that is the thing. So here process of removing surface, tool marks can be removed, surface crack can be removed. Here location, the finishing, the parallelism of the cylindrical features can be achieved, non-parallelism can be removed. So these are the features we should be remembered for lapping, awning, super finishing, buffing and burnishing. In lapping, we are using the loose dust type abrasive. In buffing, in awning, we are using the abrasive sticks. In super finishing, we are using the abrasive stones. In super finishing, we are using the abrasive stones. You can see here in super finishing, the finish is more, awning is lesser compared to lapping and super finishing. So in super finishing, good surface finish can be obtained. Okay. So these are the things. Here in awning, slow speed and large contact area. So awning non-ferrous metal, we are using silicon carbide. Silicon carbide abrasive is used for awning non-ferrous. Here on is rotate, workpiece are stationary. Both workpiece and lap in motion. Both workpiece and abrasive store are in motion. But in awning, workpiece are held stationary. In awning, workpiece is held stationary. Next, we are going to discuss about the difference between turret lathe and capstan lathe. In turret lathe, turret is mounted on saddle. Here, turret is mounted on ram. So cap ram. So turret is mounted on ram. In turret lathe, the turret is mounted on saddle. So saddle directly slides on the blade. Here, ram slides on the saddle. It is used for larger and heavier work. It is for smaller work. Capstan lathe is for smaller work. Turret lathe is for larger and heavier work. Now we are going to discuss about the gear manufacturing process. In gear manufacturing process, the most important process is gear hobbing. Gear hobbing, it is the fastest method and it is the produce the best accuracy, not suitable for cutting, bevel gears and internal gears. Here three movements are possible. One is ob rotate and work rotate and ob radial feed. So ob rotate, ob feed, work rotate. So these are the three possible motions in gear hobbing. So ob rotate about its axis, ob moves into workpiece during feed and moves parallel to the axis. So these are the three movements possible in the gear hobbing. Next, what are the gears made by different process? For small module gear, we go for gear forming operation. For worm gear, it is made by rack planing. For internal gear, we are made with the gear shaping with pinion cutter, or broaching also internal gear produced, stamping also internal gear can be produced. For thin gear, when the gear is very thin, we can go for gear stamping. and for large gear it can be used for gear casting. For die cast gear, it is suitable for only low melting temperature metals, and spur gear can be produced by extrusion method. So these are the different process where different gears can be produced. In gear shaping, left hand thread clockwise direction, left to right feed take place. Right hand thread we are producing means it has to be rotating the counterclockwise direction and left to right feed. So this is a setting in the gear shaping. For left hand thread clockwise rotation, left to right feed. Right hand thread counterclockwise direction, left to right feed. And we are having gear finishing operation. Gear finishing operation is gear burnishing, gear shaving, gear lapping. These are all gear finishing operation. These processes are gear manufacturing operations, and this one is gear finishing process. So what are the different mechanisms associated with the different machines? So quick return mechanism, we are having quick return mechanism. It is associated with the shaper. And a tumbler gear and apron mechanism is used with it is used in the lathe. Indexing mechanism, it is in the milling machine. Regulating wheel, it is used in the central grinding. Geneva mechanism, it is used in the turret lathe. So these are the mechanism associated with the machines, different machines. And here in shaper, ratchet and fall mechanism is there with the clapper box. So next we are going to see about the cutting tool and its application. We are having different cutting tool. Trepanning tool is for large diameter holes, and a side milling cutter for cutting keyways, arc cutter for machining gears, abrasive stick for in awning, cotton fabric dipped in abrasive grains in buffing, abrasive stones in super finishing, loose dust type abrasive lapping. So these are the different cutting tools there we are having application. So trepanning tool, large diameter, side milling cutter, keyways, arc cutter, gears can be produced, abrasive sticks used in awning, cotton fabric dipped in abrasive particles buffing, abrasive stones are used in super finishing, abrasive loose dust type abrasive are used in lapping. So metal removal rate can be found out by 1000 TDV. So machining time is L by Fn, calculation of length of the turning process by D by 2 plus X plus Y. So this can be, it's a special problem. And uncut chip area calculation D by cos theta, and total machining, it is the time of single machining into N. Next, cutting speed in shaper, we are having L into N into 1 plus M by 1000. Calculation of parameter M equal to alpha by beta. Machining time in shaper can be T equal to L, open the bracket, 1 plus M divided by V. And number of strokes required, it is W by F. And the metal removal rate is F into T into L into S. The power required is K into W, and gear ratio is A minus N into 40 divided by A. So feet per minute in drilling is capital N into, it is feet per revolution. When you multiply the feet per revolution, this is feet per revolution with RPM, you can get feet per minute. So power of drilling can be noted as C into F power of 0.75 into D power of 1.8. Index crank movement, this is the important formula for the competitive exam point of view. Remaining formulas are mostly they won't ask in the exam, but you can know for the calculation purpose. Index crank movement can be calculated by 40 by N. So after knowing those formulas, we are going to focus on the few formulas. So this is a cutting speed. What do you mean by machining time? Machining time depends on the following parameters. The first parameter is cutting speed, so it is V equal to pi dn by 1000. And the feed is the D minus D by 2. And the machining time depends on this L by the speed of the tool can be found out by F into N. The speed of the tool can be found out by F into N. So the material removal rate can be calculated by this formula. It is pi by 4, it is 5 by 4. It is 5 by 4 d square minus d square into feed, or pi d times of average into T into F. So this is the formula for MRR. The material removal rate can be calculated by using this formula. Measuring time required in boring, it is L by N into feet per revolution. So it is the same formula. Gear cutting, pitch diameter equal to number of teeth into module, tooth thickness equal to 0.5 times of 5 times of module, and total depth equal to 2.25 times of module. In shaping machine, we are having different mechanism, crank and slaughter lever mechanism, Whitworth quick reader mechanism, and hydraulic shaper mechanism. So the cutting speed can be calculated by length of the cutting stroke by time required by the cutting stroke. It is length of the cutting stroke to the top, time required by cutting stroke. And M is the ratio of return stroke time to the top cutting stroke time. So finally we can get the formula, simple formula, N into L 1 plus M divided by 1000. So we can know L is the length of stroke and B is the breadth of the work. So here N is the number of double stroke and M is the ratio of the return stroke time to the top cutting stroke time. Next we are going to find out the time taken to complete the one double stroke. It is the time taken to complete the one double stroke. Total number of double stroke can be found out by time taken to cut complete cut. It is for time taken for the complete cut, the time taken for complete one double stroke. Okay, based on that we can use the formula. And milling machine, we should know the formula of average uncut thickness. This average uncut thickness is formula for maximum, and this is the one formula we have to use again and again for the milling. And effective feed per tooth, this formula can also be used. These are the two formulas has to be concentrated as per the milling machine. So it is the effective feed per tooth formula and average uncut thickness. Next is index crank movement. Index crank movement can be found out by 40 by N, and it is for compound indexing, it is 40 by N equal to small n1 by capital N1, small n2 by capital N2. The capital N1 is the whole circle used by the crank pin. It is a whole circle used by the crank pin. So it is the first plate and second plate, and N1 is the whole face moved by the crank pin, and N2 is the whole face moved by the plate. So based on the small n1 and capital N1, we can find out the for compound indexing. So for grinding, we are having only one formula. For grinding, we are having this formula. So T1 equal to square root of F pi dn C Rg. So this Rg is the uncut triangular cross section area, the uncut section approximate triangle cross section area. So that is Rg, and it is the force per single grit can be calculated by using this formula, and machining or grinding time can be calculated by using this formula. So these are the formula to be noted for the grinding operation. So these are the formula to be noted for the grinding operations. For peripheral milling, we are using this formula. And for cutting speed, spindle speed can be using this formula. The time for one cut can be calculated by using this formula. So it is total length of the cut by feed rate. Table feed rate can be calculated by using this formula. So we are having peripheral milling. The approach can be calculated by square root of small d, open the bracket, capital D minus small d. This is the important formula for the competitive exam point of view. Now we have completed the metal cutting and machining operations. We have discussed all the formulas. So it is the end of the metal cutting and machining process. So you have to practice all those formulas and theoretical content to excel in the exam. So you should concentrate on all the topics. So in types of chips and orthogonal cutting and oblique cutting, and cutting fluid and tool material, tool wear, lathe, shaper, drilling machine, milling machine, grinding machine, gear cutting machine, everything is totally covered. So practice it and it will be useful for your exam. Cheers.